Okay, welcome back. So right now we're going to be looking at some composite shapes involving the area of triangles, and a lot of these come down to a decision whether we want to add a certain area or take a certain area away. And that will become clear as we go through this. So if we look at our first one here, we have basically a rectangle, and then we've removed this triangle up here. So in order to solve for the area of this shape, one of the easiest ways to do this would be to solve for the area of the total rectangle and then take away this area of a triangle. So in this case, we can think about it as total area is going to be equal to our rectangle minus the triangle. Right, so let's do the area of the rectangle first. I'm just going to call this A1. A1 is going to be equal to length times breadth, so just 10 times 12, which is equal to 120 centimeters squared. And we'll call the triangle A2. So A2 is going to be equal to the area of a triangle, which is half times 2 times 2, and that just equals 2 centimeters squared. So the end result is going to be that our total area, which is called TA, is going to be equal to 120 minus 2, and that just equals 118 centimeters squared. Alright, let's look at B. Now B is the same idea, it's just a large rectangle, and we're just taking away this triangle in the middle. So let's get started with that. First up, our rectangle. So a rectangle will just again go A1 is going to be equal to it's going to be equal to 9 times 8, and that just equals 72. And A2 is going to be equal to, this is meters squared, is going to be equal to 1 over 2 multiplied by 9 multiplied by 6, which is equal to 27 meters squared. So our total area is going to be equal to 72 minus 27, and that just equals 45 meters squared. Alright, let's look at C. Now C is a bit different because it essentially is this rectangle, and then we've added on a triangle on top. So instead of taking away, what we're going to do is solve for the area of a rectangle, and then solve for the area of the triangle, and then add them together. Now before we do anything, let's get our unknown dimensions in. So we obviously know that our height here is going to be 4 and our length here is going to be 10. We don't know what the height of our particular perpendicular height for our triangle is. We do know that the total perpendicular height is 6, and we know that the height up of the rectangle is 4. So if we take away 4 from 6, we know that this is actually 2 centimeters perpendicular height. And we also know that the base here is going to be the same length as the base of the rectangle, so it's also going to be 10. So now that we know this, we can solve for the area of both shapes. So for our area 1, which is going to be our rectangle, it's just going to be 4 times 10, and that just equals 40. And our area 2 is going to be 1 over 2 multiplied by 2 multiplied by 10, and that just equals 10 centimeters squared. So our total area is going to be equal to 40 plus 10, which is just 50 centimeters squared. Alright, here's a few for you guys to practice, so just give the video a pause, give them a go, and then I will solve them. Alright, let's get started. So the first one here, D, we're going to realize that we have essentially a large triangle, and what we've taken away from in between is a square. So let's solve for the area of the large triangle first, and then we can take away the area of the triangle second. So for our first one, for our area of a triangle, it's going to be half times 30 times the perpendicular height, which is 20. Okay? So our A1 is going to be equal to 300, and that is in meters squared. And our A2 is just going to be equal to 10 times 10, which is equal to 100 meters squared. So our total area is going to be equal to 300 minus 100, which is 200 meters squared. Okay, just remember, every time we see the same symbol, it means that this is the same length. So this is 10 and this is 10. But all we need to know for area is length times breadth, so we can do 10 times 10. If we look at E, what we have is ultimately a rectangle, and we've added on a triangle. So let's start off by solving for the area of the rectangle. So this is going to be 60 multiplied by 5. So our area of 1 is going to be equal to 300 millimeters squared. And our area 2 is going to be our triangle, so it's going to be half times 6 times our base of 60, and that just is going to equal 180 millimeters squared. So our end result is going to be 300 plus 180, and that equals 480 millimeters squared. Finally, let's look at F. So for F, again, we've got this rectangle and we're taking away this area here that's a triangle. Alright, so A1 is going to be equal to 25 times 20, and that's just going to be equal to 500 meters squared, and A2 is going to be equal to half times 8 times 25, because this unknown length here that's the base is also equal to 25 meters. So A2 is going to be equal to essentially 25 times 4, so that's just 100 meters squared. So our total area is going to be equal to 500 minus 100, and that just equals 400 meters squared. Alright, that's it for this video. Hope it was helpful, and I will see you in the next one.